biological origin. So these are the different type of disasters. So generally in geophysical hazards, it includes some geological process like plate tectonic moment. So in some of the time, we seen that some area have some tsunami. So due to the some tectonic movement in the ocean, so there is a upliftment of some one plate. That's why the uh, water levels gradually increase and moving towards the land part. So it increased to 30 to 40-meter height in the wave form. So this is called the tsunami, and this is mostly occur in the uh, uh, some in the Pacific Ocean, and then hydrometeorological, that is caused by the water atmospheric circulations like flood, flash flood, drought, landslide. Then biological hazard, you also know the health related and some like the COVID-19. So there is a risk equal to hazard into exposure into vulnerabilities. So in this picture also shows. So suppose there is a shark and it is a signal to the hazard. So if you are exposed to these areas, then the risk is very high. So uh, the exposure to any type of hazard is related to the risk. So this is the methodologies. So this is one of the satellite image. Recently, there is a flood, mud flow of the river in, I think in, it is in Dharali village in Uttarakhand. So this is the previous image, satellite image, and this is the during the mud flow of these areas. So this is because suppose there is a satellite image. So this is the area. So, this is the area, and this surrounding all the hotels or establishment is there. So this is the highly vulnerable area. So it is advised not to build this type of structures and this type of buildings near the river, as it is a glacier fed river. So glacier fed river are very much high risky, because when the glacier burst, then enormous water flow is there with a rapid movement of the waters, and most of the mud flow also uh, creating some problem. So if there is any safety measures is there, then this type of hazards may be avoided. So this is the river, and the origin is, just see, the origin is from the all the glacier areas. So that's why it is very much high risk, and the elevation is also very high. So if the elevation difference is very high, then flow is also very high. That's why it is more vulnerable for the any type of disasters. So this is the very risky areas, and because a lot of peoples are visiting for any scenic beauties near to the river, so they build this all these structures. But in the next in the near futures, we may avoid this type of establishments, and a lot of this type of infrastructures are there. So this is also one type of, this is also one, this type of structure is also there. So this is also, I think, there's a glacier filled river. So when the glacier is melt, suddenly melt, or any moment is there, then the flood will be occur. So this is the reason of recently occurring the flood. So it is a, it's very much dangerous for nearby peoples. Then earthquake also refer to the sudden ground shaking, and most earthquake are caused by the sudden release of the energy, and Then tsunami refers to a series of ocean waves that sends surges of water. These waves sometimes reach the height of 30 meters. And these destructive surges of water cause underwater earthquake, and this event displays a large volume of water. And it is this wave travel across the ocean at the speed of 800 kilometer per hour. So in 1983, one of the example is the Indonesia tsunami. The wave were found to have height about 40 meter. I think it is 120 feet height of this tsunami. Then volcanic eruption also caused some of the hazard due to some uh, damage due to some falling of rocks and exploding some debris, and some volcanic ashes also mixed with some atmospheric constituents and form a concrete-like substances, and a lot of chemical are also releasing into the atmospheres. So these are the one of the important uh, geological hazards. So this is one of the animation of the tsunami, how the tsunami is happen. So just look like this. This is just due to the some subsidence and upliftment of the different plates in the ocean. So this is the occurring of the tsunami in 30 or 40-meter height. Then some of the example is landslide. So this is the aerial photo of some Mod Creek landslide on the May. Then second is the volcanic eruptions. Then third is the earthquake, how this damage to the these industries. Then last is the tsunami, how effect to the coastal areas. And this is the seismic zone of India, and it is prepared in 2002. So zone 2, 3, 4, 5, and zone 5 is very high risk zone. It is categorized, and it is present in the Gujarat and the northeast and some Himalayan areas. And zone 4 is a high risk zone, so intensity is 6. So some of the areas are near the lower Himalaya area and Jammu Kashmir, and also in the Gujarat. Then zone 3, so zone 3 is some part of the northern India and some western coastal areas and in some eastern coastal areas. And zone 2 is the middle part of the India and some coastal eastern coastal areas. So zone 2 is some of the low risk zone. Then some landslides includes all the process, and then avalanches due to the some glacier is happened. Then sinkhole also result from the depression and the ground due to the collapse of the surface of soil layer. So sinkhole mostly common in the karst topography and characteristics of limestone terrain. When water seeping underground chemically erodes and the underlying limestone bedrocks, the reaction is the CaCO3 when H2CO3 mix with each other, then the soluble carbon hydroxide is created. So these are the some debris and avalanches and crevasses, and B is the red lake sinkhole. This is the image. Then type of landslides. So there are various landslides are there, like rockfall due to rockfall. This is one of the example. Then debris fall, then rock slide, then debris slide, then slump, debris flow, and mud flow. So major cause pertain to geology, geomorphology, and human activity. The landslide includes due to the some increased water percolation, result in increased pore water pressures. So when the water is enter into the upper areas, then the heaviness is increases into the hilly terrains. So that's why they drag into the lower parts. Then increased weight due to the rain and snow melt and reduced frictional forces and increased pore water pressures. Then the presence of structural weakness in rocks. So if there is a structural weakness and their relationship with surface slope, then it gradually falling to the lower parts. Then earthquake shock, downslope movement, and some volcanic eruption produce loose ash deposit, resulting in debris flows during heavy rains. Then blasting for quarrying and construction of mining induced slope intensities. So these are some of the figure that is a rock fall, a rock slide, slump. Slump is generally the down movement of rock masses along a curved weak surfaces. And debris flow, we know the flow of some different rocks or different mm, mud or woody materials from higher elevation to lower elevations. And mud flow generally the composed of mud and saturated water can flow from higher elevation to lower elevation. So these debris flow, mud flows, slumps, and rock slide are generally occur in the high altitude areas. So in middle altitude areas and small forest area, there is not seen, mostly not seen. So this is the rock fall, and the photograph B is the landslide, and the photograph D is the mud flow. This is the example of mud flow. So these are all happening in India most of the times, and in the monsoon season also the mud flow and debris slide is very frequency is very high. Then different type of volcanoes are there, like central type volcano, Fisher Islanded type volcanoes, Haiwan type volcanoes, Strombolian type volcanoes, then Volcanian type volcanoes, Vesuvian type volcanoes, Pelian type volcanoes, and Pilinian type volcanoes. So based on the pressure inside the magma, so they can create different type of volcano. If there is a high pressure in the insides, then Pelian type of volcanoes are occurs. If there is a low pressure is there, then it creates some dome type of structures in the upper areas. So based of the materials and based of the pressure present in the lower earth surfaces, they create different structures. So this is the lava dome, then a cinder cone, then composite cones. So these are the different type of volcanic cones are there. Then caldera formation, when this explosive is there, then there is a depression is created. Then in this depression, some water is filled with this water. Then it is called as caldera. Then there are two type of volcanoes, that is destructive type and constructive type. So in the destructive type volcano, loss of life, property, and some of the towns are also destroyed. In constructive, the lavas produce some fertile soil after weathering, and this soil, like black soil in central India, are very fertile, so which are used for the cotton farming and other farmings. So this is the positive one of the volcanic eruptions. So in the destructive, there is a change in landscape. Large areas are covered by lavas. But in the constructive effect, that is some precious stones are also found in volcanic rocks, like diamonds in South Africa. And some of the disaster also happen in due to acid rain and poisonous fumes present in the volcanoes. And in constructive effect, that is ores and minerals deposits are extensively produced by volcanoes and related processes. And often volcanism is accompanied by some of the disastrous earthquake and soils agricultural field are destroyed most of the time. and but in constructive way, it is create a new landscape. So most of the volcanoes in the sea area, lot of islands are created with the creation of the volcanoes. So these volcanoes nowadays is habitated and one of the most beautiful tourist place. So these are created by the volcanoes. That's why some positive effect is also there and some destructive effect is also there. So these are some of the picture of the precious stones present. Then earthquake. So there are three type of earthquake is there. One is normal or shallow depth earthquake, originate from within a depth. So based on the depth, there are three type of earthquake. One is if the origin is from 0 to 50 kilometer, that is normal or shallow depth earthquake, and one is from 52 to 40 kilometer, then it is called intermediate earthquake, and deep focus earthquake, that is from 240 to 725 kilometer. So this is the scale of this deepness of this earthquake. So generally when earthquake is happen, so there is a base um, area is there. So this is called beneath zone. So what is beneath zone? So beneath zone is when the zone dipping beneath the continental margin or a island arc and having a deep sea trench, its surface expression is called as beneath zone. So this is the beneath zone having high stress margin, and this is the beneath zone with low stress margin. Basically, there are two plates when collide with each other. One is slide to lower side and one is upper side. So this zone is called Benip zone. So then cause of earthquake. So why the earthquake is occurring? So due to some collapse of caves or cavities are formed in the action of underground waters, and some landslides, massive landslides also cause shaking in the surrounding areas, and blasting of rocks in the mining area. Some blasting also occurs, some temporarily earthquake. So it is not very big waves, but it create an earthquake. Then volcanic cause is also one of the important earthquake moment. And the tectonic cause. So it is very much dangerous. If the tectonic moment is there, then this create a large loss to the earth surfaces, and it is the intensity is very high. So tectonic is very much dangerous tectonic moment. Then this is one of the uh, volcanic eruptions animation is there. So this is the crust, and this captures all of the magma from the upper mantles, and these are the layers, lower and outer cores, inner core. So it is called as the lithospheres. Then these are the plates boundaries. So when they collide each other or any subsidence are there, then some earthquake is happen and some eruption of magma in the island also happen. So generally the oceanic plate is very heavy as compared to the uh, our land part plate. So oceanic plate is very, so it's generally subsidence to the lower part. So this is happening for this the continental plate. Then the
Sir,
constructive
what were
plate
the two
margin.
kinds of, excuse me, what were the two kinds of that tectonic plates that you showed? They varied in terms of the color. One was like in the initial part of the video, one type of tectonic plate was colored blue, and the other type was colored red. When you showed initially, when Earth, lithosphere, that diagram, Earth was divided into, yeah. So here, yeah, you see, yeah, before
Oh,
that, yeah, here, this part, yeah, they're highlighted differently. So when the video runs,
okay.
then yeah, here it was like blue in color, and the one near the Persian Gulf coming to the Indian subcontinent, that was, I think, red color.
Red is not there. Okay, just
I think,
okay, okay, okay.
yeah, you see, yeah, this one. So this one was like red color, and the other one was like blue color. That it between the Atlantic Ocean, between the
Yes, sir.
Americas and Africa.
Okay. Actually, because this color is for the frequent earthquake is occurring in these areas. So this is the very highly earthquake occurring, or when the volcanoes are there, and also in the Pacific Ocean. So these areas are very vulnerable areas. So most of the time there is any volcanic eruptions are there, and very active volcanoes are also there, and some plate tectonic movement are frequent in these areas. That's why it is. I think it is created the red color, and mid oceanic ridge also there in these areas.
I think that was blue. Yeah, this one was like
This
in
is the mid
blue color.
oceanic.
So here the
Uh, this is the some constructive volcano, I think. So when the two plates are apart from each other, then it creates some magma, and this is the constructive volcanoes, and this is the destructive volcanoes. These areas. So one plate is collide with another plate. So this is the reason in these areas the oceanic plate um, collide to the continental plate. So this is the constructive volcano, and this is the destructive volcano. Sorry, destructive volcano. So just see. So this is the constructive plate margin. So second is, I think it is a divergent, and first is the convergent. Convergent means at colliding each other towards each other, movement of the two plate towards each other, and in the divergent, that is constructive plate margin. So they away from each other. So this is the divergent plate margin, and two plates separate each other, then the magma come out from the lower part of the earth. So this also creates some of the mid-oceanic ridge and the elevations, and some of the islands also form. So this is the divergent plate margins, which is formed in the red dots are there. So this is also called as ring of fires.
I think it must be convergent if it's destructive. In Ring of Fire, I think the volcanoes are destructive, like
No,
it
no,
was in the previous.
so this is the divergent, uh, because the two plates are diverted from each other. That's why it is formed. So One thing is that the
What
ring
are
of
what are those what are these spots, these triangles, these places that are marked by triangles? Are they like the volcanoes?
this is the divergent plate margins. So maybe sometimes it creates some volcanoes, but this is becomes some divergence and some plates can be apart from each other. I think it is not divergent because in USA there is a divergent. It is not. It is a convergent margin. I think because previously it is showing because the ring of fire is in these areas. Sorry, yeah, uh, mid-oceanic ridge. So mid-oceanic ridge is the example of the divergent margin. Okay, we can see in next slide. I think it is possible. So these are the magma chamber. Then volcanic bombs are there. Okay, then we will see uh, some geoinformatics in the disasters. So, in the disasters like flood, earthquake, cyclone, landslide, avalanches, biology disaster, accidental disasters, all these link to the geoinformatics and all the database are created. Then some non-special attributes like populations, topography, land cover, geology, infrastructure, and also integrated with this. So all these informations and communication links are also there. So like drone, UAV, satellite, GPS, internet, and ground truth imagery. So all these are links to the GIS platform. So any type of happening is there or any forthcoming of any issues are there. So the warning system warn all the communities. So in Odisha, there is a warning system created in Disaster Management Authority. So if there any type of cyclonic effect or any type of flood warning is there, so in the coastal areas, in the every village there is a warning siren is there. So before happening these events, the sirens can be warn all the peoples that it may be some risky or any type of hazard or any type of problem is there. So this was first initiated in Odisha, and a lot of other related remote sensing based technology are used for the preparedness of the disasters, and also estimation of some infrastructure safety measurements, and preparation and construction of some sea wall to protect the coastal communities and plantation of mangroves in the coastal areas to protect the communities from cyclones. So likewise, all the natural infrastructures and artificial infrastructures are both happening and continuously it is uh, ongoing. Then also in interferometry, that is INSAR. So it is a synthetic aperture radar system in remote sensing that uses two or more synthetic aperture radar images of the same area taken at different times. By comparing the phase difference of radar signal between these two images, the scientists can detect ground deformations with centimeter to millimeter accuracies. So it is very much helpful in analysis of earthquake measurements. So generally, earthquake cause sudden coastal movements, uplifts, subsidence, horizontal shifts, and INSAR detect these changes by generating interferogram. And INSAR provides special continuous deformation maps. So this helps identify the extent of the rupture zones. And after all, in the post-earthquake, some hazard assessment also prepared with the help of INSAR images. and it is also useful for identifying area risk of secondary hazards. And one of the advantages, seismograph gives point-based wave recordings, and while the INSAR gives spatial map of ground motions, can detect silent earthquake not easily recorded by seismograph. So this is the INSAR synthetic aperture radar. So when the initial ground is like this in the upper areas and the subsided ground is like this. So when the wave is coming from the initial ground surface, so their wave is like this. But when the subsidence is happening, so this E, that the change in the phase is recorded. So sudden phase changes are recorded in the satellite image. Then it map that it may be some subsidence or any earthquake or any type of disturbance is happening in the landscapes. So these data can be recorded and then analyzed for whole areas. So this is the technology which is used for, with the help of the synthetic aperture radar. So this is the satellite image, some of the previous pre-event and post-event, and this is the satellite image of some which is landslide damage to the railway station near the Assam. So this is the railway station. Then this is the train. The damaged train is there, and this is the pre-event of some of the landslide areas. Then post-event, so how this is changes, we can calculate and how much the effect and how much area is affected. Then we can calculate with the help of temporal satellite images. This is of the landslide areas. So previously there is no signal of this any events. So we can change, we can analyze using the different satellite images. Then some geo information based disaster response chain is there. So field based informations, counter eligibilities, then suitable satellite, this type of satellite data are used, and elevation informations. Then it is linked with the, some communications and some GPS based informations. All are linked with for the disaster response. Then meteorological hazards generally happen due to the atmospheric disbalance and weather climate related phenomena. Like some of the examples are tropical cyclone, hurricane, typhoons, thunderstorm, lightning, and tornado, water sports, and heavy rainfall and floods, and heat waves and droughts. So these are the generally occurring the meteorological hazards. So these are the name of the different tropical cyclones in the different areas. So like cyclones in the uh, Indian Ocean areas. Then in the Pacific Ocean there is typhoon, and in the American coast there is hurricane. So this is the how this is created the cyclone. So that generally the water vapors from the ocean surface and comes into the contact with the cold air, then form some clouds. Then this column of the low pressure is created, and winds form these columns. And at the pressure center column, there is a weakness is present in the eye areas, and then speed the wind around it, and it increases. So this is the general thing. Then how the remote sensing is helpful for this weather forecasting and all these things. So there are two type of satellite image are there. That is geostationary satellite, which is fixed at a particular point and continuously monitoring all these areas. And these polar orbiting satellites from North Pole to South Pole, it is revolving around this. And geostationary generally they are in the 35,000 or 36,000 kilometers above the equator, and it stay fixed over one locations, and it continuously monitoring all the cloud storm and large scale weather system. Some of the example of the satellites is INSAT series, Indian satellite series in India, GEOS that is from NASA USA, and Meteosat that is from European Space Agencies. Then polar satellite is generally in the low height, that is from 700 to 800 kilometers, and it provides high resolution data, that is NOAA series from the NASA, METOPS that is from Europe, and SCUTSat from India. So instruments and sensors on weather satellite generally use radiometers, which measures visible infrared microwave radiations, then sounders that profile atmospheric temperature and humidity, scatterometer that is measure wind speeds and direction over ocean, altimeter that is generally for height information and monitor sea surface height. Then imagers that take some visible infrared and different images. So Indian weather satellites, which are launched by the ISRO, is INSAT 3D, INSAT 3DR, which are geostationary weather satellites, and SCUTSat-1, that is ocean winds and cyclone monitoring. Then OceanSat series, that is ocean color and surface wind. So generally, ocean color monitoring is useful when there is a seaweeds are there, some seagrass are there, and some other ingredients are there and some floating vegetations are there. For this, the sea color monitoring is very much helpful, and in some areas there is a pollution is there. Then different application in environmental pollutions. So there are different pollutions are there in the environment, like land pollutions, water pollutions, and air pollutions. So most of the time in soil contamination, we use the hyperspectral data, and because of the lot of bands are there. Then land degradation, we generally use some LIS4 in satellite image, false color image for monitoring the soil erosions and salinizations and desertifications. Recently, there is a desertification atlas also released by SAC Ahmedabad. Uh, so they are using only LIS4 satellite image, and some field visit informations are there. Then waste disposal mapping, then decision making, landfill site area
So, sir,
selections.
can you please repeat the point on land degradation that list for you was saying?
Actually, I have also working in this land degradation atlas. So in the land degradation, we just see in the three season satellite data, that is Kharif, Rabi, and Jet, three type of satellite, three type of season cropping patterns data. Then we just see which area is generally not cropping is not available in these areas. So in the three season, we just see the land surfaces using the satellite least four satellite image, that is 5.8 meter resolution. Then we just calculate all these areas, some of the agriculture, forest, and all these areas, and some salt saline affected areas are also found most of the time in the Bihar and UP sides, and also in Punjab, due to the over water intake for the use of the agricultures. So that looks like some brightness is very high. In the saline soil, the brightness gives the high saline areas. So these are monitoring, and some erosion areas also found some cyan color and different textures are there also. So these are mapped with the help of some satellite image, then create some desertifications mapping with the use of some NDVI calculations, and soil indices are there, and some of the field verification photographs also taken for the final estimations. So generally land degradation we use previously, that is land list 3 data is used, for recently the list 4 data is used. So you can see the land degradation atlas. So it is also available freely. Just a second. So this is created by the SAC Ahmedabad ISRO. So all these data, all these atlas are freely available. So DSM, this is desertification monitoring, and some land degradation atlas that is in prepared in 2018. Uh, Desertification status monitoring, that is DSM. In this side also some of the application and some of the software are also previously available, but now it is available or not, I am not sure. So there are all applications already completed in this SAC Ahmedabad. All are uploaded in these sites like air quality monitoring, urban sprawl information system, hydrological science and applications, wetland. These are very applications is there.
So there is nothing in urban sprawl information system,
Urban sprawl information system is there. I just see whether it is for
but there is no output.
output. I think it is a application. So any atlas is there. Let me just see. Space-based observation of Indian wetland, snow cover, spectrum of every NG copy, archaeological, planetary science. No, the urban area atlas is not presently showing any atlas, but soul line is present. For Odisha, West Bengal, there is a. You can check all this with the use of this website. For different states, there is a soul line change. And this is the
So
urban sprawl.
application.
It is just a application just to show all these areas because the PDF file is not available.
Where can we find the documentation behind this? Because urban sprawl, in order to identify sprawl, we need background information also. So, what kind of information has been taken in order to identify? Where can we find the documentation regarding urban sprawl?
For which urban areas? For any state.
Let's say any particular given state. What is the classification? What is the definition that they have used? How to classify whether a particular unit is urban or rural? Where can we find this documentation behind this?
No, actually urban and rural are defined by their states, municipalities, and state governments. So they define there is the urban areas and this is the municipalities and this is the urban local bodies or NAC, Notified Area Council. So it is in the all the states.
For statutory town, yes, but for census town, and there is also a concept called outgrowth. So that's why I'm very curious. What kind of definitions have they used? Is there any documentation? Where can we find that documentation? Because for our purpose also, we have to identify urban agglomeration.
Okay, so
So
maybe
we can confirm.
so actually. day by day there is a changing of the statement that some of the area is declared as a urban areas. So it is the state has some dynamic records, and in I think in the Ministry of Urban, is there any document is not there? Ministry of Urban.
No, it is urban in terms in census terminology. There are different concepts. One like what you mentioned, statutory town. By notification, state government gazette notification, a particular area is declared as a municipality. There might be a change in the status, or there might be addition of surrounding villages. Then there is a concept of census town. So there
Hmm.
are particular criteria like population, the occupation, density, and then there is another concept called outgrowth. And
Hmm.
based on all these concepts, we identify urban agglomeration. So I would like to understand whether our what we identify in our department and try to see whether this particular interactive map correlates. So in order to understand this map, I would like to know the definitions and the concepts that are used to create this map. So where can I find the references for generation of this map that is being shown here?
Actually, urban outgrowth is these are calculated in for research purpose or any other purpose, but it is officially not declared. This is the urban outgrowth, and this is these areas. So it may be provided by the state government, and is ISRO also working in the urban areas for finding out what is the outgrowth is there. So I think they still not provided officially that this is the urban outgrowth is there. So if it is happen, then I will discuss with other my scientists which are close to me, because I have already worked with different scientists in ISRO. So if there any information, then I will provide you after asking and
Thank you.
consultation with this. Okay.
Thank you very much. So that would be very useful.
Okay. Okay. This is the land degradation vulnerability assessment created by the SAC Ahmedabad. So basically, they use only least 4 satellite images, and NDVI calculations. So this is the vulnerability index, very low, low, and high, very high, based on the land vegetation index and some land erosions patterns. So for all the states, it is available. All the maps are available. Then you can take it as a reference. Okay, so then there is the land pollution, then water pollutions, then the air pollution. So Tropomi now, recently 2019, it is launched. So it is very much used for the monitoring of air qualities. And MOD is also very much time used, and OMI is so used. So I have just prepared different landscape maps having the change in the methane gas emission from 2021 to 25. So these are the areas in the the high methane emission is happening in the North Baleswar areas, because in these areas the wetland water content is very high, and 3 times there is a crop, rice crop is cultivating. So rice crop giving the high methane emissions. So rice is one of the highest emission of the methanes. So this is the area. So cropping pattern, due to some cropping pattern, and this is the Chilika area. There's a water body is there, so there is a low emission of the methane gas. So this is the pattern. So you can use Tropomi. It is freely available. Mode is also freely available for nitrogen, sulfur, and carbon dioxide. How this emission is present in the atmospheres. And for oil spill, chemical spills in the water and in the sea, that is SAR data is available. and this is the applications of different geoinformatics in the environmental pollutions like land pollution, water pollutions, and the air pollutions. Okay, then we'll next class is tomorrow 6:30. We'll discuss some basics, then practice some practical, some basics practical using QGIS. Okay. So I will share all this PPT. So no problem. I will, in this. So just give me your mail ID. Then I will give you all this PPT. Okay.
Okay, sir. Thank you.
Okay.
Thank you, sir. Thank you.
Thank you. Thank you.
Thank you.